My guest today is Dennis Chow. Dennis is a multi-industry and seasoned cybersecurity operations leader. Using his experience, he helps organizations achieve their maximum security potential through hybrid training, SecOps management, engineering, and cross-disciplinary integration. He's also a published author and a veteran of the armed forces. Thanks for being with us on the show today, Dennis. It's a real honor.
Thank you. Honor's all here.
So what originally brought you to my attention was a post around a book you've written and are about to publish. What motivated you to write Automating Security Detection Engineering, a hands-on guide to implementing detection as code, and who is the primary audience for this book?
Now that you say that title out loud, I probably should have did a better job at that title. I wrote it because teams, including detection engineers, security engineers, SOC, and fusion centers, they don't have the proper automation around the use case lifecycle. There's plenty of books and materials out there on how to be a detection engineer and the skill sets surrounding that. They don't know how to do great management. So as you're melding the DevSecOps need and model to security operations, this is kind of what this book is about. So if you're looking for a target audience, I would say security engineers, detection engineers, or very advanced analysts, perhaps level 3s, in the SOC that are already creating signatures, but need to take it to that next level, like measure things, how they are performing, automation around scaling. So if you're using different clouds, on-premise, etc., this is probably the book for you. And it's really focused around maturing our our use case development lifecycle as opposed to creating the use cases themselves.
Okay. I'm curious how you came to this kind of career. I read your LinkedIn bio. It mentions that you're a veteran. How do you go from being a veteran to becoming a security engineer that's using software development practices applied to cybersecurity?
So I entered the Air Force in 2004, and to be honest with you, I didn't do anything in security. So you get your A+, your net plus, and you try to earn extra money while doing IT support. This is way back in the days, showing my age. And so I went in as 3C doing computer systems analysis, and I wasn't an officer. I went in as an enlisted. So I wasn't qualified to do cyber at the time. There was just nothing out there for me. I just kind of went into IT thinking that it was going to take a long time to get into security, and eventually everyone gets their big break. So for those of you out there that are not trying to get into security, keep trying. Someone's going to get your break, but you got to learn the IT foundations first. Fast forward again, SOC analyst work all the way through engineering and back. And it's you keep progressing forward. The most important thing that you have to do in this career is like your free time, at least for a good chunk of your time, is not your free time. It's certifications, it's projects, it's waiting for the right opportunity. It's networking, even for introverts like us, or maybe perhaps myself. And you're having to force yourself to the next level and next bubble. So in contract work and all that great stuff. So eventually your resume gets piled on and people keep calling you. And if you keep publishing content and portfolios and open source tooling, someone's bound to pick you up. So that's where, again, falling into pen testing after putting my time in the blue team side, as well as analysts and engineering. And then I went back and did people leadership. And all of a sudden, detection engineering becomes a thing in the later years now, right? So we've been so specialized that you really can see how we used to be all in one, right? The SOC was everyone. Mm-hmm. You used to be an engineer in the SOC too, by the way. So now we have threat intelligence, detection engineering being the latest push button topic. And part of it's a luck, to be honest with you. And, I just kept choosing to keep that door open. Every time someone knocked on it, they said, "Did you want to go and do this?" And I said, "Yes." And so, that's where the hopping went, and just keep going forward.
Very cool. Yeah, paying your dues. I liked how you mentioned your free time's not your free time in those early days. I still don't feel like I have any free time, but I had more energy back then. So,
yeah, man, you're eating us out here.
So for listeners that may not be familiar with the concept, can you give us an overview of what detection as code entails and why it's important?
Sure. There's plenty of that have coined the term detection as code. In reality, just like serverless, it's all code. The difference is that we're using those DevOps concepts, and maybe DevOps is an archaic word now. I think people call them platform people for some reason. And at the end of the day, detection as code means build a pipeline, related that's usable for all things detection. So whether you're creating EDR signatures, you're creating behavioral or focus items, you're creating anything that is an artifact out of your purview, you actually put that through testing and automation, and then it gets automatically deployed ideally, not to just one system where you could have just done that by yourself, but to many systems. So in many cases, if you're in a large shop, you may have two scenes, one for your corporate side, maybe one for product. And then if you're, perhaps doing business with the government, FedRAMP, you might have a FedRAMP required, moderate or high level scene by itself. And so you have all these different environments. How do you scale? And so that's what really it's all about, scaling the detection engineering side. And then also coming back around full circle, as I mentioned earlier, the deprecation, the performance monitoring, all that becomes part of the automation as well, but that, perhaps different maturity cycles of detection as code. So that's the way I see it. And I feel like that's the second part of that, performance monitoring deprecation, is sometimes missing in the conversation when many places focus on the pipeline by itself.
Mm-hmm. Yeah, and I've even seen a lot of benefit from keeping detections in a repo so that you have that sort of peer review process and the sort of change history and kind of taking that software engineering principle over, right?
Yeah, yeah. Ultra great low hanging fruit win. So if you're like an immature shop, or perhaps not immature, you're growing. If you haven't reached that level of creating runners quite yet, you can still achieve a good chunk of starter detection as code by simply using that repo. So back in the day we had SVN, you had Git, you might have GitHub versus GitLab now. It's all the same concepts at the end of the day. So different workflows, but at the end of the day, change control is where it's at. We have the tooling. Developers have had this for a long time, and it's time to pull the security operations people and security engineering people into the 21st century and beyond. And that sounds like a sales pitch in itself, but you have to really learn how to do change control and tracking, and then do that peer review. And what I see today is they may use a Jira ticket, they may use a ticket somewhere else, perhaps ServiceNow or email, and it's just lost in the fold. So even if you're just doing version controlling, there's so many cool plugins that you use for syntax checking, and makes you a better engineer overall when you're exercising all the tools available to you.
Yeah, I'm going to date myself again and say that you mentioned SVN and I had a little shudder run down my spine.
Yeah, I have some bad memories of that one too.
Yeah, I remember blowing away like huge chunks of work and not being able to get it back.
Oh yeah.
So what are some of the core principles behind detection as code? Like, is there a higher level philosophy, and can these principles improve the effectiveness of security operations overall?
I think so. I think what people have to remember is you don't have to be a detection engineer specifically or a dedicated team to practice this, right? You could be all in one SOC that kind of does everything, and you start this practice down solo, independently. So I want to make sure that you can scale this without scaling people. Second of all, I want to make sure that people know that as you create signatures, and I say signatures, I mean this could be for IOCs and IOAs and full TTP behaviors. You don't have to just be a signature on an AV. They can be a full AI model for all of those, as long as it's your output. The most important thing is having modularity in what I call, developers already know this, runners and CI pipelines. These runners are your change agents that actually do the checks for you. And so as you're creating a folder structure in your repo, as you're creating signatures or deciding how to actually implement a signature that the end implementation will read as opposed to what you put through the pipeline in formatting. And I call that the payload versus, payload detection as opposed to DevOps practices detection. So you may have a full snort signature or circodic signature inside a YAML file because it's easier to parse, with that level of modularity. So that's the second main principle of it. The third is, exercise all use cases of developer DevOps and DevSecOps. So how do you think like a developer? And they're going to be, this is nothing new to them, right? So unit testing, integration testing, some form of testing, even if you're starting with the most basic testing of syntax checks. There's a lot that can go wrong with that. So all things automation needs to go around the build process as well as the deployment process. So that's kind of like the second and third principle there. I think the last one is monitoring. And that's not monitoring in terms of after you deploy the use case, so this use case will work. That's should be part of your testing. It's monitoring the use case for effectiveness of the organization as a whole. So so the automation can get really crazy. So dispositions and scenes, case management. If you look at positive, true positive and false positives, positive, benign, and however you decide to utilize your taxonomy, you have to get that feedback put back into your team. Now, for a lot of people, this is still asynchronous, very manual. And so if you can get that back into the form of Jira tickets and monitoring when the last change to the section was, you can actually create really good proactive reporting. And in your own essence, kind of like hunt digging or red hunting digging for your own, signatures and effectiveness. And I think that can also prove to be a valuable efficiency that SOCs are not doing today, or even fusion centers are doing today. It'll take some elbow grease, but you can eventually get there in phases. And I think that's really it for the high-level principles. It's a lot, though, to implement besides just the discussion of it, at least.
Yeah, and maybe again for listeners who might not be familiar, you mentioned runners. Can we just explain how that concept works at like a high level of you make a change to a detection rule or some part of the pipeline, and how does that all unfold?
Yeah, let me put it into a couple of analogies for some people. So for those of you who understand a little bit of cloud, that is event-driven stuff. So think of a serverless function doing something on your behalf as soon as an event arrives. That's what you could think of it as a runner. For those of you that are still kind of on-premise or you don't know cloud, think of a log metric or a log change or a configuration event that happens on, let's say, a Windows system. All event happens here, hook here, do something, and then you monitor the status of the job. All it is a script or a change agent that runs as a function after you put something in. And with GitHub and many modern CIs, you can also do it as a cron job. So it's any event that triggers a function, one or more scripts on your pipeline that's saved and specifically built for processing your one or more use cases.
Beautiful. So yeah, if there's an organization listening and they're intrigued, they've maybe heard about this a little bit, how can they go about starting to implement detection as code? We talked about putting detections into repos, but what can they do if they have a legacy system in place?
So if you have legacy systems in place, I think the most important thing about any of this is understanding what your API solutions are capable of doing. And I say API solutions, I mean, does your tool support any form of programmatic access for the management plane? So if you have, some people talk about SIEM, but the EDRs are the likest to do. A lot of EDRs are cloud. So if you look at CrowdStrike, Microsoft ADP Defender, and whatever their name is now, is there a development kit, first of all, and check to see if that's that. That would help you determine if you can actually do scalable deployments. If that's a no still, you still got legacy systems that you just can't get off for some reason. Let's say you're running a super duper old version of Q8R for whatever reason. You can at least do the change control management side of versioning directly to the repo. The challenge with that is you have to look at the first part of it as not just, I created a repo, I'm dumping everything in there. You got to really think through the folder structure. How much testing are you going to do, if any, through an automated pipeline, at least the CI portion of it. And then do you need to make any changes structurally to the payload? And by payload, I mean the section in itself that goes directly into or is supposed to go directly into the solution. So if you look at perhaps CrowdStrike or something like that, they'll have a different way of implementing their IOA, custom IOAs, custom IOCs as signatures. And so do you use YAML, AR, and then how do you structure it inside? And surround them with metadata, right? The taxonomy, the TTPs. So those are the things that we should be architecting first, regardless of the maturity of your deployment structure itself. And if you spend that time, you'll get a lot out of it. You might even get other action items from risk perspective and assessments that you're missing in taxonomy or you're missing in detection coverage overall. So it's a great exercise to do. It might take you a couple of days to do across a couple of people, and that's how you can get started quickly. And then I guess the last portion of a tactical perspective is you don't have to always do SIEM. Like SIEM is like one of the downstream kind of places that a lot of people like to start off, but you can also start upstream too. So let's say your main business is a cloud provider or a SaaS solution. Think that the WAF, the main WAF that you're using at all, Is that easier? Does it have API access? Can I do a one-for-one, drop a file in and have it interpret it directly as is, or do I need to manipulate it? And you start with one solution first, you can pivot the same concepts to everything else and really make a robust program. Otherwise, you're just going to be doing the same thing I think everyone else does.
Yeah, so this is a little bit of work to get installed. It's definitely going to make the analysts and operators and engineers' lives better. How does it improve the security posture?
So let's say you have I'm just going to use cloud as an example, Wiz or Sysdig, whomever, and they're focused on the CSPM or posture management. Or let's say you're a Rapid7, shop or whatever you're doing. I think the most important part from a posturing perspective is how fast can you get mean time to detect. So for those of you that's in leadership, or those of you that are communicating with leadership, it's always about mean time to detect. And then from the SOC perspective, from the shift right perspective, mean time to validate after your detection is fired. And so you can reduce that time to the lowest possible number practical. You're showing your immediate value from an exposure perspective, and you're showing your immediate value from a response perspective as well. Now, from the vulnerability management side and exposure, it's more of a configuration thing. That's still mean time to detect from your world as a detection engineer, which equates to how fast did you discover and validate said vulnerability, even on the TVM side. So you don't have to be a SOC analyst to actually appreciate how fast we can do it. So it's all about rapid speed and QA, because you can still have false positives inside a vulnerability scan or exposure alert as opposed to perhaps a traffic alert from a firewall or something like that.
Mm-hmm. Very cool.
Yeah.
So for these things to be successful, like how much does the security engineers, developers, and detection engineers, how does that collaboration work?
What successful places I've seen do this is, UKG one of them is to use Jira or figure out a way of operationalizing it. A lot of places that have this trouble initializing detection as code, maybe it's because of an OKR that your CISO says that I have to do because of the board. First things first, get your workflow management solidified before you do anything else. So whether it be Jira, Snow, ServiceNow, for instance, however you do it, other than email, hopefully, is like make it standardized. And so once you have those, you can start collaborating with them, and then you can actually pull metrics. And I personally had plenty of experience with Jira systems, and we make epics, and we have user stories for the most part, and put in the request and track it. What's the criticality of it? What's the taglines and hashtags? And that helps us figure out where we prioritize our finite amount of resources as a leader to say, hey, security engineering needs us to validate something here before they pop it in for us. Versus, hey, the vulnerability management team found, or risk team found a low severity exposure that doesn't have any validation around a proof of concept or something like that out in the wild. And so that's how we prioritize it going forward and how you can collaborate. I think the most important part for individual contributors outside of a people leadership perspective, this is if you're going down into the weeds. I've had my team, and they were kicking and screaming when I when I implemented this and kind of enforced this. Story points, 1 hour for one. It can be a 1-to-1, one point for 1 hour spent, minimum of 15 minutes. If you need a non-trivial thing and it takes more than 15 minutes, it's a freaking user story. Tag each other inside Jira so they can notices and respond to each other accordingly. And that's the collaboration I found to be really to expedite the process. And then before you, if let's say you've picked Jira, for instance, even free edition, go to the vendor's website. And there's a lot of great content around how to use Jira, what is Git, what does the commits mean, how does the workflows happen. And you just go to the small little labs or you just try it out yourself. You'll find it's not so scary. So I found a lot of these people have used the classic systems. They just don't want to touch it because they go, oh, that's developer. That's not my mindset. I'm like, you guys got to really change that because this is how we scale as a security operations group and an engineering group.
Yeah, really getting some buy-in to one of those tools and using a tried and tested process, right?
Oh, absolutely. Yeah.
And I have to ask this one because it's sort of the one thing everybody's talking about today. How does machine learning and artificial intelligence, play into detection as code, and can it be used in that sequence?
Yeah. So my book talks about a couple of ways of use cases of them, and And I want to make very clear AI in terms of Gen AI and AI in terms of the traditional machine learning and regular statistical based AI that you'll more likely tune. Um, from a Gen AI perspective, there are two facets of the detection as code kind of like program. The first one, helping you generate it, right? So helping you validate, let's say you pull content from an RSS feed, and this is also in the chapters too with the lab, and transform it into a prompt. It spits out whatever knowledge reference that you have, and you review it as a human, and it becomes something you start testing and playing with in the development cycle. So that's the front end of it. The middle side of it is that, let's say you just don't have time to write all the unit tests, or you just don't have necessarily the skills and capabilities. You still use Gen AI using the LLMs and the APIs. With that, craft a custom prompt every time you send those payloads in, and then see the probability of success based on what success looks like from previous examples. And so that's one that you can utilize almost immediately and quickly. You just have to make sure that you're careful about your iterations as you eat up those API token licenses. Mm-hmm. And then I guess lastly, from an ML perspective and more of a traditional AI perspective, other than cheating with LLMs, and I say cheating, I mean using it for your assistance, is really looking at the disposition. So this goes into the I guess third or fourth pillar of monitoring and performance. What is the likelihood of a use case performing well over time as opposed to not? So when your regression comes to mind, what is the likelihood of something that looks like this that's going to be a high ratio of false positives at month 1, 2, and 3? As you tune it down, you can actually utilize that for your management of your resources, both technically and as people optimization. So who should be working on what, tuning, optimization, enhancement, and identification.
Very interesting. Yeah. And I thought you were going to say that you were using Gen AI to write unit tests, which I was going to share some of my pain where I've seen it hallucinate so much and haven't been able to craft it. But I think, using it as returning a probability is a much more useful and reliable way to use that kind of technology.
Yeah. I've seen the newer stuff out that people put out for writing its own unit tests, but I think that really applies better for pure functions. So if you got Python, for instance, and that's your whole code-based development, I think it's easier for it to do it because there's so many more examples out, especially on like the stack sites and stuff like that. I think you can also augment that by a voting system of LLMs that are separate and discrete. Yeah, it's just longer in the unit testing pipeline side where you have two LLMs, two different managed. They have a probability of a scale of 1 to 10. You can use it as a weighted score on your end, so it's kind of augmented there. And you have a cut score that fills the build, regardless of what their items are, because of a weight. So you can actually have more than one, but your costs go up accordingly because of that.
Right. A lot of API calls. Can you maybe touch on the importance of testing and validation and detection as code? We talked about unit tests. What methods are most effective for this?
Yeah. So for those of you out there that are new to developers and stuff like that, when we say unit testing, we mean testing usually at a function scope level or an object level. And when they say integration testing, you say APIs talking to other APIs, and end-to-end testing to some people means, does the use case work under a bunch of different conditions, edge cases, etc., fuzzing, whatever. I would say testing is very incredibly useful for detection engineering people or focused people, simply because of the fact that you're going to be tired. Let's say you're doing development on 4 different technologies. That's a lot of shops have to do. How are you going to context switch between them? How much efficiency loss you're doing? And that's why you need that automated testing inside the pipeline, in line at least. There's inline testing where you're doing the build process, regardless if you're deploying or not, or just staging. And that acts as your second pair of eyes before it even gets to the time of another analyst or another engineer. So if you think about the cost of a PR request and someone actually human reviewing, let's say there's 200K engineers at the same time. What is 1 hour of review and testing and tweaking when the first guy should have did that? Mm-hmm. That's a bunch of money lost over time. So if you use AI and you're looking at pennies and cents, correctly tuned, obviously, this is going to help you quite a bit in the cost perspective and help you sell to leadership as well. I think the other aspect of that is, what is the scope of your, if you don't need inline testing, out of band testing with the non-inline asynchronous ones. You can always come back and use a breach adversary simulation tool or leverage your partnership with the pen test team. Just know that there's the amount of testing that goes on there is always after the fact, after the implementation, and it's much more involved. That's more of an end-to-end and integration perspective. So really pick and choose your battles there, but at least do some form of testing so that you're not going around spinning your wheels. And in fact, AI can actually help you with some of that and say, well, did you think about this? So based on if you're creating a similar shoot off from, let's say, a Chronicle scene test, what does that metadata say based on the researchers? Do you still meet the same criteria as the intent of the proof of concept or public exploit at the TTP level as opposed to an easily changeable string? So AI can still help you with that testing as well beyond the human. I think that's something that you need to really be careful about in our field.
Yeah, 100%. So yeah, I'm sold. Maybe there's some listeners out there that are sold and they want to go bring this to their leadership and they're going to get the resources. They're going to implement it. It's going to be expensive. How do they show the ROI? I think you mentioned a couple things along the way, but what kind of things can I put forward as KPIs to track or measures of success that in a year from now I can show we did something worthwhile?
Oh yeah, definitely. I think the time of creation, right? The amount of time, the lead time it creates from, let's say, 0 day to your research time in development into a proof of concept signature and then ultimately one by end-to-end life cycle. That's one for sure. How you measure the different components is going to be up to you and your instrumentation of your tooling, right? So that's why we're very adamant about using a known tool like GitHub and perhaps Jira and start those counters there with lots of integration. The other one I want to ask to make sure at program level that they monitor is look at not just the output ratio, but also the effectiveness scores of your return feedback, right? So make sure you're collecting, even manually, the disposition information of your SOC analyst. So for those of you that are perhaps Splunk enterprise security users, there's a disposition analyst button there. You can pull those reports out using the REST API and get the categorization number and then look at that for every one of your TTPs and then map those TTPs back to your use cases. And in that way, you can kind of cluster and prioritize your items from a leadership perspective and also show where you're kind of heavy and where you're kind of light on. And that shows you where you're putting your ROI is, as long as you're tied to threat-informed defense, which is a whole different other set of conversations. I was getting there, man. I was getting there. But if you do all those things ahead of time, you tie that back to threat-informed defense. And that way, you've got content for everything, but you've got the OKRs in line to make sure that leadership knows where your priorities are at all times. Mm-hmm. And if you don't have a threat-informed defense program, use your CTI program, use whatever you have for CTI and say, that's why, right? Closest to your clustering of your industry. I think the last thing for me is, what is the cost of implementing and try it out? So a lot of CISOs are out there that want to do this and want to try it out. Try it out small scale, right? Start with the easiest technology that you can't mess up. So you have an IDS, let's say it's Zeracata based, or you're using Corelight with Bro, or Zeek now. Try it out, right? It's not going to hurt anyone in line. So if you fumble on your repo, there's always a rollback. What's the cost of using GitHub Trial Edition for teams, right? It's less than $100 a year for a lot of organizations. So set a little budget, let's say $1,000 for the year, right? That's achievable in a lot of places, and give it a shot. Give it a weekend. Turn it into a gamification. I love doing this with my teams. Spending shutdown a couple of days, focus on trying to implement this stuff, come out with an MVP process flow, and then iterate over time. And now you've got skill sets, return on investment, and then motivation for your teams to actually get to the next level.
Yeah, no, and I love the investment in developing people's skills as a positive outcome of this kind of thing, because you are bringing everybody up, right? They're going to start to get more ideas, find new solutions, make things more efficient. Yeah, really cool. Okay, so besides your book, which I'm going to link in the show notes, do you have any other resources or books that you would recommend to people who want to get more involved with this type of cybersecurity?
Sure. If you're listening to this and you're early on, you're not even near detection engineering yet, that's okay, right? I guess the sister book to this, or my predecessor book, was not me, but Megan Brody. She's a SANS instructor over there and course writer, and she actually co-authored the Practical Detection Engineering book from Packet. So same publisher, just look from them. They're kind of like you read this first and then you read mine second. If you're looking for generic ideas on detection engineering and the automation around this as a whole as well, maturity-wise, I'm looking at you people leaders. There's a community detection engineering maturity matrix that's done by one of the SANS community members as well. And then lastly, I want to point out, and DEATHCON, DEATHCON, not the other side. 2024 is happening in another month or two. I'll be doing a workshop out there, but that's dedicated for detection engineering and automation and threat hunters. And check them out. It's a really reasonable, workshop set, remote and on site. And I think those are some really good resources. And other than that, keep building, do stuff. If you like making red team tools, do that, and then figure out how to detect that. If you've already evaded someone, and that's going to help you get to your next skill set and perhaps to your next job.
Yeah. I think we talked about that on the pre-call we did before this interview. The people today just really needing to spend the time building things to develop.
Lean in. I got to tell everyone, lean in. I'm a hiring manager. I was, and I still am. Certifications get you to the door. Your portfolios and how you communicate yourself actually help you finish getting through the door. So just keep that in mind. If you're wondering about what you should be doing with your career, try something. It'll help out.
Awesome. Okay. The last one I have for you, it's the one I ask of everybody who comes on the show. It can be as wide or as narrow as you want. Do you have any predictions for the future of cybersecurity?
Man, I'm going to make a lot of people hurt. And, I had this theory like 4 or 5 years ago. I was talking about this to another recruiting agency. I made this timeline. I think we're in generation 3.5 of the cybersecurity industry maturity. Gen 1 was mostly architecture, InfoSec practices, and stuff like that. Gen 2 being NetSec focus heavy. Gen 3 being more AppSec and API driven. We're kind of then 3.5 with OT, ICS kind of making its way back and way back down. Then we're kind of like Gen 4 in the early stages of AI. As you look at across this huge timeline, what's future in security? The only thing that you see is automation and the rapid acceleration of that automation. So I think, honestly, we're all going to have to become security researchers at one point. So if you're not following like Chompy or Malware Unicorn or some of the other like crazy researchers out there, start doing so, right? And start thinking about how you can shape your career going towards, because at some point, I think AI is going to get mature enough where could be years, could be several years down the line, you're still going to have, even though you might have jobs now, the demand is going to reduce, your pay of demand might be reduced too. So what's left next? The stuff that AI has a hard time doing today and possibly in the near term tomorrow. And honestly, that's going to be probably security research and bug bounties and stuff like that.
Mm-hmm. Very interesting. Yeah. I think that's the first one like that I've gotten. I love it. I actually put these all together at the end of the year, and we do like one mega episode of everybody's predictions. So
awesome, man.
Yeah, I appreciate you coming on the show, Dennis. This was a great conversation. I think full of valuable stuff for people interested in sort of taking their operations to the next level. So thanks for taking the time.
All right. Thank you for having me. Have a good one.
Yeah, cheers.